All right, we're going to continue our transformations. We've already done these before, and we're going to still apply them to the trig functions. So given an equation y equals sine x, write the equation if it's shifted 2 units to the left. So remember, the key number when you're dealing with x shifting right-left is 0. And what would you have sine of what, so that when we plug in 2 it gives a 0? It'll be x plus 2. So when we plug in -2, we get sine of 0. And so our 0 is being shifted 2 units left. We can take a look at this. X plus 2. I can change my, go to window, make the x scale 1. Actually, let's go to -6, not -6 pi, -2 pi. And so we'll hit graph. And yeah, we can see that this point right there, which is our standard sine, was shifted 2 units left. Similarly, let's look at the cosine. We're going to shift it pi over 2 units right. So that would be y equals cosine of x minus pi over 2. We can check that on our calculator and just change this to cosine and say x minus pi divided by 2. Let's look at our scale, our window. So our x scale, we want to make it as pi divided by 2 so we can see it. That's the only reason for that. What do you see there? Here's pi over 2, and cosine normally starts high. What does this graph look like? And so this is right. You should recognize that. That is the sine graph. All right. In general, we're going to look at our equation, which will be y equals a times sine of b times x minus c plus d. Now, we've already looked at these. We have, just to recap, a is our amplitude, absolute value of it. B is the number of complete periods in one normal period. Or in other words, b period equals 2 pi for here. C is our shift right left. Right or left. And then D is our vertical shift. In other words, up down.